Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a reaction to an article published on InfoQ. The name of the article is Architectural Trade-offs, the Art of Minimizing Unhappiness. And I think this is a very important theme because many developers who want to become architects and many architects who are in their first years of software architecture don't realize that there is more to software architecture than just writing code, and that part of it is actually making trade-offs. And software architecture is basically an art of making trade-offs. So before we start, I'd like to give you some thoughts that I have and some things that I tell our learning participants on about software architecture. And the first thing is how we define software architecture. So fundamentally what happens is that software architecture is about decisions that affect more people for a longer period of time. This is not a perfect definition, and maybe you can find others, but honestly, this is a perfectly good working definition, one that I noticed people understand and can use and reason about. And these are strategic decisions. This is what strategic decision means. You make decisions that affect more people for a longer period of time. Now, how many people for how long, that depends a lot on the organization. And once you understand that, you also understand that you'll make decisions whenever we talk about strategic decisions. And it doesn't matter whether they are technical, whether they are political in nature, whether they are business decisions. You always have to make decisions without having complete information. You make decisions with incomplete information. And the reason for that is typically what happens with these types of decisions, the only moment when you have complete information is after everything happened, and then you know. In the case of architecture, the moment you have perfect information about the product that you're trying to create or make decisions about is when the product is in production and it's useful, people are using it, and it's kind of at its peak, like the highest level of usage. That's when you have, and that's too late, right? You cannot wait until that moment, and actually often you cannot get to that moment unless you are making some decisions. So because of this, all architectural decisions are trade-offs. All architectural decisions are trade-offs. And these trade-offs often are invisible for people who don't know that this is the nature of architecture. People who think, yeah, let's just do that. Yeah, but that compared to what? What are the trade-offs? What are you trading for what? And there's one thing I like from the book Software Architecture and Engineering Approach, I think it's called Modern Software Architecture and Engineering Approach, something like that. I'll put it in the description. What the authors are saying there is that you are aiming for the least worst decisions. You cannot make the best decisions, but what you are aiming for is the least worst decisions. So this is pretty much the introduction in our architectural workshops. We have two of them, one for developers who want to become architects, from developer to architect. The other one is for architects want to clarify and classify their knowledge. We have others more in depth on various styles of architecture, but these are two that match here. So with this in mind, let's look at what this article is saying. So this is an article published on InfoQ, June 4th, 2024, written by Pierre Pureur, experienced software architect, Kurt Bittner, VP of Enterprise Solutions at Scrum.org, and reviewed by Thomas Batts, laureate application architect at Blackbaud. And we've heard these names before. I did some review of other articles on software architecture on InfoQ, and typically they are pretty good. So I'm interested in seeing where this is going. Key takeaways. To architect is to be a frustrated perfectionist. A good architecture minimizes this unhappiness by making trade-offs that can be lived with. Yeah, I can put it this way. The main skill in architecting is making trade-offs, yes. These trade-offs reflect the most important and difficult decisions a team will make about its architecture. The impact of architectural trade-off decisions can only be evaluated by building something and testing it, usually in the real world. This is basically what I was saying. You cannot wait for more information because you'll never have more information. I think in some cases you can have more information without actually building something and testing it. But it's true that in some cases this is what happens. You really need to build, test it, get feedback. And by getting feedback, I mean, part of the feedback is how many users are using this feature and how is the system adapting to it and so on. Being able to generate reasonable alternatives is important, and much of this comes from experience working on similar problems in similar contexts. This is where experience matters. Getting good at forming hypotheses and running low-cost experiments to evaluate trade-off decisions helps team make better trade-off decisions. This is such an important point, and I'm honestly, one of the things I keep telling architects is we should do more experiments. We should do more. Whenever you are faced with a decision, you should figure out ways to gather more data through experiments. It's very important. Software architecture, like life, consists of a series of trade-off decisions made with incomplete information and often under tremendous time pressure. Teams seeking a perfect software architecture are going to be unhappy, but despite its imperfection, the alternatives are worse. Brittle, expensive systems that can't evolve and eventually can't be maintained. Software architectures are driven by quality attribute requirements, most of which are unknown at the time architectural decisions are made. However, it is nearly impossible to satisfy all of an architecture's QARs, which leads teams to make trade-offs. Okay, so they are talking about quality attribute requirements. There are alternate names for that. I used to call them, for design, desirable design characteristics. But that's at the design level. When you talk about architecture, most of these quality attribute requirements that they talk about, they tend to be linked with the cross-functional requirements like performance, security, scalability, usability, and so on. And you always have trade-offs between those because let's just think for a moment about security versus performance. So in many cases, if you want more security, what does that mean? It means you need to encrypt something else. It means you need to add some more checks someplace. And what this translates into is longer response times which means less performance. And this is one of the obvious ones, but you have a bunch of these that are that are not as obvious, let's say. Trade-offs make teams feel bad, like they have failed somehow, but they are a necessary and even essential part of getting a solution to market. Software architectures, especially enterprise architectures, are often based on a set of principles and standards that teams want to follow as rigorously as possible. Making compromises that do not follow these principles and standards to deliver a workable system often disappoints team members. And I think that's the wrong way to look at it. Don't expect things to be perfect. You can write your code to be, and that's why I'm kind of separating design versus architecture, because when I talk about design, I talk about the structure of the code. And there you have much more leeway in making decisions. You can name things in certain ways. You can structure the code in certain ways. It kind of gets cemented after a while, but you always have refactoring to fall back onto, and you can always kind of improve your designs as you go along, if you master the refactoring techniques. But of course that takes time. So there's always a trade-off, but my feeling is, and actually my experience, not my feeling, my experience is that it's less of a trade-off when it comes to software design than it is for software architecture. When it comes to software architecture, everything is a trade-off. Okay. For software design, we also have trade-offs, and they are often not visible to programmers. One of them, by the way, is if you use clean code, the domain of applicability of a technique is important. So domain of applicability of clean code is when the developer cycles are more important than the computer cycles. What we mean by that is we make a trade-off between making the code extremely fast, like under microsecond fast, picosecond, nanosecond fast, versus the developer time. And if in your context you don't care about nanoseconds, picoseconds, then you're probably better off in adopting something like clean code that allows you to reduce development time. So there are some trade-offs there as well, but generally speaking, we have more information there. We have more leeway. We have more space to make our own decisions. Whereas when we go into software architecture, these are fundamental things. You cannot just go around them and say, okay, we'll do something else. Or no, it's just the way it is. The art of making trade-offs is, in many respects, a matter of minimizing the team's unhappiness with the architecture. No architecture is perfect, but they can be good enough. What constitutes good enough is worth exploring in more detail. An analysis of the architectural trade-offs can provide a lot of information about the architecture itself and especially its risks, as demonstrated by the architecture trade-off analysis method from CMU CI. Oh boy. I think this was part of CMMI or around CMMI. Yeah, I'm not familiar with this method, but generally, the Software Engineering Institute had some pretty good ideas, but often they were too bureaucratic. So that's why I'm not so sure that's a good method. I would have to look at it. Architecture involves finding solutions to unknown problems, yes. As we have noted in other articles, architecting a software system evolves from attempts to make the system satisfy its quality attribute requirements. What makes this especially challenging is that many of system QARs are unknown, at least initially, and some of the ones that are believed to be known turn out to be wrong. In addition, QARs can be deeply interrelated, as in the case of scalability and performance, so that a complete solution to all QARs is often impossible, hence the need to make trade-offs on making decisions. QARs are unknown largely because no one knows how successful the system will be at the point when the system is being envisioned. For example, if the system isn't widely adopted, there is no need to make it scale, that is, per large number of users, and it sometimes takes time to understand the real need. QARs turn out to be wrong when they assert that the system needs to achieve something that turns out not to be true. For example, when a business sponsor says that the system only needs to support thousands of concurrent users, when in reality the actual need is 10 times this, or vice versa, when the system never achieves the popularity that would demand high levels of concurrency. Yeah, that's typically the question that you ask. So for business sponsors, it's also the number of users who adopt is often an ego thing. They want to look good, so they would plan for a lot more users than expected. Yeah, it's the job of architects to figure out a good estimation here, knowing that it's a guess. So you can always kind of make the point of the population, target demographics, and percentage of users who would use this thing. But yeah, it's not always obvious. The main skill in architecting is making trade-offs. One might think one of the most important architecting skills is to accurately forecast QARs given the high cost of getting them wrong. No. Being able to foresee the future is always useful, although elusive. We don't have crystal balls. Or we do, but they don't tell us anything. But even if teams have perfect QARs, they are still faced with having to make trade-offs that result from being unable to completely satisfy competing QARs, such as cost and capacity, or performance and scalability, or time to market, and just about everything else. I like this one. Right, so the best time to market is when you don't have to build anything. The second best time to market is when you build just one small feature, you deploy it, and that's it. But is that enough to bring you users? That's the question. The critical skill in making trade-offs is being able to consider two or more potentially opposing alternatives at the same time. This requires being able to clearly convey alternatives so a team can decide which alternative or neither acceptably meets the QARs under consideration. What makes trade-off decisions particularly difficult is that the choice is not clear. The facts supporting the pro and con arguments are typically only partial and often inconclusive. If the choice was clear, there would be no need to make a trade-off decision. A team may need to make a decision between synchronous and asynchronous communication between services, which requires making trade-offs between performance and scalability. A performance QAR could be easier to define than a scalability QAR, especially when a new product is first being rolled out. The requirement for the system's performance may be clear. For example, the time to process a specific transaction should not exceed X seconds with n concurrent users. However, the scalability requirement may be undefined at this time, as it will depend on how successful the product will be. The team may decide to use asynchronous communication between some key services to ensure future scalability, but this could negatively impact performance. On the other hand, too much reliance on synchronous communication could negatively affect scalability and create technical debt should a new product turn out to be very popular. It's very interesting. It's very interesting because generally speaking, okay, there is also a matter of consistency. and of programming time. Typically, asynchronous communication requires more attention, more testing, a different type of testing. So there's also that. It's not only that it's performance versus scalability. I think we should also take into account programmer time. And the next question is the team at the level when they can deal with asynchronous communication for everything? So that's another thing that I would take into account. And okay, I understand that they are talking about the teams here, but honestly, I feel that the final decision should be the architect's. If there is an architect. If the architect role is distributed within the team, then fine, okay. But you should have a kind of, well, you don't necessarily have to have a person who's an architect. You can have the team take over this responsibility. That's perfectly fine. That is a distributed model. On the other hand, if you do have a software architect, I think they should be both responsible and accountable for this decision. And by accountability, look, well, I mean, we know that no decision will be perfect. So that's not the point of accountability. The point of accountability is to learn from past decisions. That's where it gets very interesting. So, and even if the team is doing that, there's also responsibility, accountability. So they picked asynchronous. It proved it wasn't great. They should be able to explain, okay, so this is what we didn't understand. This is what we didn't know back then. Absolutely okay. And the whole reason for this is for them to learn and hopefully for other parts of the organizations to learn. What often separates architectural decisions from other design decisions is that you can never be sure the architectural decisions are right. Each decision is really just an educated guess, a hypothesis that must be further explored by building something, releasing it, and gathering feedback. Sometimes, even then, the trade-off remains. It is sometimes impossible to completely satisfy a set of QARs. All you can know is that the decisions you have made are currently adequate. Making decisions that seem adequate now can lead to unintended consequences over time. Take quantum computing, where vendors decided to focus on usability by hiding complex critical components of the software stack. As described by Vlad Shirboarian, Meyer, van der Grind, and Jake Muff in their ICSA 2024 conference paper called Exposing the Hidden Layers and Interplay in the Quantum Software Stack, this decision resulted in performance limitations in current qubit implementations. Yeah, interesting example. I'm a bit familiar with quantum computing, but I'm not sure how the vendors decided to focus on usability by the complex critical components. Okay. I would have to watch this or read this paper. Releasing is the only way to evaluate trade-offs. No amount of pure analysis is sufficient to evaluate trade-off decisions. Real-world feedback is the only way to tell if the trade-off is acceptable. Yeah. This is what we discussed. So it's really, you don't know. Okay, so you have to make, and now ideally you would make let's say you have two options. You would make those two versions and figure out which one is better. But generally speaking, you don't have the time and the money to do that. So you have to make a decision. And one thing that is worse than making the wrong decision in this case is not making any decision. Because if you're not making any decision, you're just delaying everything. If you are making a wrong decision, you'll find out eventually that you need to change and in what direction to go. Now, with this being said, there's a concept from Lean, which is the last responsible moment. So you can delay decisions, the architectural decisions, up to a moment, which is this last responsible moment. Problem is, you only know what the last responsible moment is after you passed it most of the time. So there's no perfect way of doing with this. It's a lot of intuition and a lot of dancing with the system, basically. A simple example illustrates this point. Local caching of data can improve response time by eliminating remote data access over network, but it can also reduce concurrency if caches become out of date, and it can reduce performance if the local cache have to be frequently refreshed. Both of these can vary a lot in a dynamic system. How much to cache and how often to synchronize cache data depends on how often the data is accessed and how often it changes, both of which depend on real-world usage. The only way to evaluate this kind of trade-off is to build and release the part of the system that implements the trade-off and then look at how the system responds to various kinds of load. Yeah, and I would also love, this is another thing that I'm not seeing enough, particularly if you are talking about scalability and performance under scale. You can use existing tools to make a graph of, let's say you build something and then you can use existing tools to make a graph of response time versus number of users. Because you can simulate multiple requests, it's not very simple, right? Because you have to define kind of what are the common actions that a user would take in your product, and then test on that flow, or maybe decide just to test on an endpoint. So there are some more decisions here, but it's basically engineering after that. You're just measuring how the system reacts under different levels. Now, there are other factors that may complicate this. One of them is infrastructure costs, because you can scale this up and have to pay things, to pay cloud providers. And then there's also a matter of dependency at databases and so on. What is stored, how close is the testing system to the production system, and so on. So there are a lot of factors here, but still I believe it's very useful to have this graph, because at least it will give us a trend. If it will tell us this thing is increasing linearly, or it's increasing exponentially, or kind of goes linearly up to a point and then it increases very quickly. You know, there are things you can extract from there that are helpful and that you can then take and discuss with the business. If the business, let's say you have a kind of a graph that goes linear, but then it goes up very quickly after a certain point. Let's say that point is a 10 million users per second. I don't know, something like that. In that, and if your business is asking for more, you can then tell them, are you certain? Because up to here it will cost us that much per request, and then it will cost us that much per request. The cost will increase dramatically. And so we maybe will need to work out a different way of dealing with that. So these are very useful things that I don't see many teams doing. Releasing an MVP always involves business trade-offs as well as technical trade-offs. The business trade-offs involve guesses about whether users will find the release appealing and compelling. Yeah. So hypothesis on the business side. And by the way, another way you can look at requirements is hypotheses, because that's what they are and that's why they change. Meeting tight timelines always involves leaving something out in the hope that what is released is valuable. The organization may be unsure that there is even a market for a particular product. Until they are sure that there is demand for the product, they will only want to build a very limited MVP. Honestly, most of the times I don't see that. Most of the times I see business pushing a lot of features and then kind of negotiating on an MVP, but not quite. It's more like a lot of people shouting and wanting things. At least but that's typically the organizations that call us, because they have issues, of course, in this case. I'm curious what your experience is. Do you define an MVP clearly and it's minimal, or do you often feel that you're building what managers ask? In most cases, in most cases, releasing an MVP also creates a set of architectural trade-offs, which usually involve guesses about how much architecture is enough. But if the product is successful, then they may have to address scalability and performance issues very rapidly. And even for an MVP, there are some trade-offs which are non-negotiable, such as minimum security requirements. Since the architecture for a system consists of a set of decisions and almost all of these decisions reflect trade-offs, the minimum viable architecture for release is mostly a set of trade-off decisions. These decisions almost always generate a lot of technical debt. Releasing a system means making trade-off decisions. Each release consists of a set of compromises, each of which creates technical debt. If the compromise works out, the technical debt may not need to be resolved. But if and when the compromise becomes unacceptable, you'll need to repay the technical debt by rewriting some portion of the system to try a different trade-off. Reducing technical debt itself is inherently a challenging trade-off, and one that many organizations fail to successfully manage. They are under constant pressure to increase the functionality in each successive incremental MVP, but in doing so, they also usually compound the technical debt related to the associated minimal viable architectures. That's true. And that's actually a problem that I often see, where if you start with an MVP, which is generally speaking a good idea, you also start with a minimal set of trade-offs, and then the product grows, the architecture grows, and then you'll have to figure things out. One thing that people don't want to hear, but which I think is very true, is that you'll probably have to rewrite your system about 3 times to get it right. So upon the third rewrite, probably that's when it will be right. And part of this rewriting can be done through refactoring instead of rewriting. Part of it might be that, okay, we need to completely replace this component with another one that makes another set of trade-offs. And one way that I think this would work better if we would start with smaller prototypes. And first we'll have a small prototype, maybe something, we talked about this actually in a video that's called incremental versus learning or something like that, where basically explain that the way you can do incremental software development. And I think we'll need to go lower in terms of prototyping. Maybe you'll have a prototype first that is command line and work with that, and then switch to the MVP, and then know that you'll have to do a third pass. And after that, you'll end up with a good architecture. And this only if things grow organically. When black swan events happen, like maybe your software becomes very popular overnight, that's a completely different story. That's when you need to reevaluate everything. You can't evaluate trade-offs in technology you don't understand. Teams who are inexperienced in specific technologies will struggle to make decisions about how to best use those technologies. For example, a team may decide to use a poorer fit technology, such as a relational database, to store a set of maps, because they don't understand the better fit technology, such as a graph database, well enough to use it. Or they may be unwilling to take the hit in productivity for a few releases to get better at using a graph database. In this instance, they are trading the time it would take them to get familiar with the graph database against the technology fitness of a relational database, which may impact scalability, performance, and maintainability, so they are trading time against these QIRs. The solution is not to avoid potentially beneficial technology, but to use incremental releases to learn more about how the technologies work and how to work around their limitations is possible. Framed as experiments, trying out new technologies when the risk is low can pay off later when the team finds a problem that the technology uniquely solves. Yeah, and watch that video if you haven't, if you don't get this part with incremental work, because that's basically what we detail. Your trade-off decision only has to be good enough. Sometimes teams struggle to make trade-offs because they know that none of their decisions are perfect because the decision is made at a point in time. The good news is that any trade-off only has to be good enough right now. The bad news is that if your system is successful, your trade-off decisions probably won't be good enough for long. The reality is that every decision is compromised and will need to change at some point in the future. But the only way you will ever learn more is to make decisions and then build and release something. You will get feedback and you probably will have to respond and most developers understand this. Unfortunately, not all managers have learned this yet. They want to hear that decisions are final and will never change. As a result, the other essential architecting skill is being able to explain the rationale between trade-offs to managers who can't or don't want to understand the technical details. This is because of an inherent truth about decisions. They are easier the less you know about the problem. Easier, but usually wrong. This reminds me of a saying about advertising, which is that half of your advertising budget is wasted, but you don't know which half. This is kind of the same thing with these decisions. We have this problem of unknowable things. There are things that we just don't know until we get there. And because of this, we need to change the decisions. So, yeah, as an architect, or if you are a team that takes responsibility for architecture, you need to be able to explain to managers trade-offs. And because of that, you need to understand trade-offs well enough so that you can actually explain them. How to get better at making trade-off decisions. Now, this is interesting. Unfortunately, good judgment comes from experience, most of which comes from bad judgment. There are, however, some ways to improve the learning process. Get better at generating reasonable alternatives. Yeah, this is something I'd like to see, and we kind of practice. We do practice in our workshops. Don't expect technology to make decisions for you. While generative AI can make trade-off decisions for you, it can provide inspiration for alternatives. Yeah. So you can ask LLMs about different alternatives and ask for summaries, but you'll still have to make the decision. Get good at forming hypotheses and running low-cost experiments that yield results quickly. Yeah. And it's useful here to have a very good target. So it's not enough to say, let's say you need to pick between a relational database and a graph database. What are the things that you are looking at? What are the factors that you take into account? And it could be performance, scalability, the things that we have to learn in order to make this work. And so you might implement a very small feature in both relational and graph. Look at the code, look at the performance and scaling abilities of the two, and then also discuss what are the differences in terms of programming model and how much do we have to learn, how can we test those, and so on. So yeah, but you have to be very careful, because what you measure is what you will get. If you only measure one thing, like scalability, for example, that's the only factor you will use. And typically that's not enough. Be willing to admit you're wrong and pivot as quickly as possible. Yeah. And you need to be... So architectural decisions, like code, is outside yourself, right? It's not your identity. Just because you made a decision in the past, it doesn't mean that it's you. Those are the decisions we took. We made the decision with the best information and with the best abilities that we had at that point in time. But time has passed. So we are now at a different point in time. We'll learn something more. We have different sets of abilities. Of course, things change. Understand the cost of rolling back decisions that later prove unworkable. Yeah. So sometimes it's useful if you can kind of isolate these decisions, but it's not always possible. So it's good to think about how would we or modify this, roll back this decision. But honestly, many times it's not possible to optimize for this. Conclusion: perfect architectures don't exist because the QRs that drive the revolution are partially unknown and sometimes inconsistent. As a result, trade-off decisions are inevitable and essential. These trade-offs are never perfect, but they can be good enough for the system to survive and thrive. The main skill teams need to make those trade-offs is to be able to balance the relative benefits and drawbacks of different alternatives to make a choice that at least partially meets the architectural goals of the systems. The impact of architectural trade-off decisions can be fully evaluated through reviews or discussions. They can only be assessed by building something and testing it, usually under real-life conditions with real users. Because teams work under extreme time and cost pressures, being able to quickly generate reasonable alternatives is important to help them make decisions more quickly. Yeah. Teams who do these things well end up with better architectures. They may still have doubts about some of their trade-offs, but they are at least supported by the best evidence available at the time, and they are better prepared for new information in the future that may force them to reconsider. The teams may not be happy with all of their trade-offs, but their users are happier than they would be otherwise. And I think that's the main point, right? You need to think about the users, and is it good enough for the users? And it will never be perfect for the users. The same thing applies at the product level. Same thing applies at the business level. It's the nature of strategic decisions. It's basically the same thing. Only in this case, it's technical strategic decisions. So it takes into account a bit more things that are technical in nature, and the technical that the nature of code, the fact that it's more in an idea that's in your head rather than something that you can touch and feel. Absolutely. So let me think. I think this article is really good. It's is definitely useful as a mindset for anyone who deals with software architecture. They can be a manager or they can be, so you can share this with your manager. I highly encourage you. Or if you are making architectural decisions, it's also good for you to think about this and reframe software architecture in this way. Yeah. Okay. Really good article. I enjoyed it. So what do you think? You know, we love comments. So have you seen some of these situations? Do you understand software architecture better? Are there any things that you'd like us to insist upon regarding this topic or regarding other topics around software development? Let us know in the comments. That's it from me. Thank you kindly for the view. And until next time, remember to think, design, and work smart. See you next Saturday.